Good afternoon, and on behalf of the Center for the Study of the Presidency and Congress, welcome to our discussion today about semiconductor supply and the challenges to innovation for the United States. A very important topic, timely enough to be covered as a 60 Minutes feature last Sunday, and one that many members of our audience today have joined us for conversations related to already over the course of the last year or more. We started over 2 years ago a program at CSPC examining geotechnology competition, how the United States can remain competitive with competitors like China. On a range of high-tech issues. We've delved into 5G and advanced communications as one of our key focus areas. And the issue of supply chains is one that comes up consistently. Where are we getting our supply from? Are we getting it from trusted networks? Are they allied suppliers? Are we able to produce what we need here in the United States? If not, why not? And how can we plan better to do that in the future? We have had persistent national security related issues on that topic. Last year, during the COVID crisis, we also learned a lot about the resiliency of many aspects of our supply chains. At the same time, we're on the cusp of amazing new technology applications that are going to revolutionize, and indeed already are starting to revolutionize the way we communicate with each other, share data, and what we're able to do with devices like our cell phones, opening up all sorts of exciting but also challenging questions about how we keep those secure. So we're very pleased to have a longtime friend, Susie Armstrong from Qualcomm, with us today to share her thoughts and expertise on this topic. And very happy to have Jimmy Goodrich from the Semiconductor Industry Association to give us a view from the industry side. I will go to them in just a moment, but I'd like to, before I do that, recognize my partner in all of our national security endeavors, Chairman Mike Rogers, if he has any opening comments. Mike was the chairman of the very important Intelligence Committee and has also developed an expertise on this set of questions connected to his time in public policy, but also as a corporate leader now in cybersecurity and in 5G and advanced communications, and is very much a thought leader, particularly on the 5G issue. And so I'm proud to have him as my bipartisan partner on our work at CSPC. Mike, if you would like to say an opening comment, if you can hear, I'll give the floor to you now.
Hey, thanks, Glenn. Certainly thanks to the panelists. I apologize up front. I'm having some technical difficulty, but I can't think of a more important topic at a more important time. When you think about all of the challenges, consumer demand changes, certainly I think at the time when sanctions were on China, we watched Chinese companies stockpile as well as not only equipment for manufacturing in the semiconductor business, but also materials. That led to where we are today, where now you have automobile companies losing market share based on their access to semiconductors and microprocessors. So I'm excited about the opportunity to hear the panel today and look forward to the conversation. Can we, as a country, make sure that we don't run into this problem for national security purposes and still maintain an international commercial focus? I think the answer is yes, but the challenges are ahead. So with that, I'm going to leave that to you and the panelists, Glenn, and thanks for having me.
Thanks, Mike. With that, let me turn it over to Dan Mahaffey to go ahead and share our discussion. Thanks, Dan.
Thanks, Glenn, and thank you all for joining us. As the director of our Geotech programs and policy programs at CSPC, I'm happy to be hosting this discussion. And first, I want to turn to Susie Armstrong, the Senior Vice President for Engineering at Qualcomm. Her expertise in this industry is extensive, working with providers, station makers, handset makers, and really understands the innovation industry and the role that public policy plays in fostering this great innovation ecosystem, as we like to call it here in the U.S. So, Susie, thank you.
Thank you, Dan. And thank you again for inviting me. I think this is, of course, a critical topic, and it's a topic near and dear to my heart, not only because I work for Qualcomm, but for me personally as well. So there's 3 points I'd like to make in my opening comments here. And the first is that R&D is critical. The second is that legacy node is critical. And the third is that running faster than China is critical, if you will, the competition comment that Glenn made. So on the R&D point, we were talking as we were getting ready for this seminar, this panel. We were talking about the U.S. rollout of the vaccine, and the fact that we are so, as Americans, we are so fortunate to have, a Johnson and Johnson, a Pfizer, a Moderna, these big companies who have put in the long-term research and the long-term development into these vaccine platforms such that they can come up with a safe and effective vaccine in 1 year is just astounding. And it's the analogy I want to draw to the semiconductor industry. It's very critical that we look at manufacturing and access to manufacturing, because if you don't have manufacturing, you have no way to actually manufacture what you design. But we cannot lose sight of the fact that the R&D that is put into semiconductor conductors is actually where the U.S. leads. It's ours to lose, but it's where we lead the world, and it is a critical part of that semiconductor leadership. It's also from a national security point of view and a cybersecurity point of view. It's the R&D phase, it's the design phase when you're designing a semiconductor, where most of the functionality and the security features get put in or not put in, as the case may be. So that R&D leadership in the form of both companies that have their own manufacturing, like Intel, and companies like Qualcomm and Micron, who are fabless, is really, really critical in this whole picture of how we are going to address this issue of access and dependency. Legacy node chipsets are critical, and so I think we found this out, and the auto industry found this out in the hard way. So if we have a great graphic, and I didn't bring it with me, but if you look at a cell phone, which is the industry that we supply chips to, the auto industry and everybody else, but if you look at a cell phone and you look at the number of chips in a cell phone, the number of chips that are leading edge technology, that is below 14 nanometer, if you define it like that, is 5% of those. It's our Snapdragon, it's high-end memory, and the other 95% of those chips are done in very old process technologies, what we call legacy or mature node process technologies. So the conversations about how does the U.S. get on our soil or on allied soil leading edge, leading node manufacturing is absolutely critical. But we need a holistic set of policies, and we need a holistic approach, because missing any one of these legacy node chipsets, whether they're power management chips or something else, can gate the shipping of the whole device, or the whole. We're seeing it now, I think, in the automotive industry. So that's a really critical piece of the conversation, which fortunately is starting to come out. I think people are starting to realize that it's not just legacy node. And the last point I wanted to make is in the opening comments is that running faster has always been how the U.S. has stayed ahead in any technology area or in any medical area. And Glenn mentioned the competition, the critical competition, and how we prevail in those competitions, especially with a country with a lot of competent people like China. And I think that's a really good way to look at this is how do we maintain that running faster effect? There's a lot of discussion about decoupling from China, and there's a lot of discussion about how over the years and how we block certain technologies and such from China. But I think the way you actually win with China is you continue to outrun them, and that partially goes back to the support for the R&D, but it's also a recognition of the fact that both the supply chain and the market is very tied up with China. China makes the world's, I call them gizmos, everything from sensors for your electrical, your baby monitors, your phones, and even beyond consumer devices, and they also play a very major role in the supply chain as well. So you have to look hard when you're talking about decoupling from China at doing that with a blunt instrument, and doing that in the short term could really end up sort of shooting the U.S. leadership in this area in the foot. And so thank you very, very much again for inviting me. I think I saw the list of Dan's questions, and so I think this will end up being a very interesting and informative discussion. Thank you.
Thanks, Susie. And now I'm going to turn to Jimmy Goodrich. Jimmy Goodrich joins us from the Semiconductor Industry Association. He's their vice president for global policy. He's also a member of the executive committee at the Beijing-based United States Information Technology Office, where he represents SIA in that capacity there. He's worked there extensively and has experience working for U.S. tech companies in China, so understands this from the international supply chain and industry perspective. So, Jimmy, thank you for joining us.
Thank you, Dan and Susie. It's always a pleasure to be with you on a panel talking about our industry. I think just to open this up, I'd like to provide a few thoughts about how we got into the situation with the shortage today. What are some of the long-term trends, and what are some of the solutions that might be in front of us for policymakers to consider to ensure that we don't run into what happened last year with COVID again for another industry as critical as semiconductors. And as pointed out, semiconductors enable everything that is digital. If it has an on-off switch, it has a semiconductor in it. Whether it's your toaster, your garage door opener, whether it's a supercomputer, an F-35 Joint Strike Fighter, the over-the-horizon phased array radars for naval weapon systems, everything is powered ultimately by a semiconductor component. And many of those, the semiconductors are the brains that make all of that digital innovation happen, not just for yesterday and today, but also in the future. If you think about 5G, artificial intelligence, even quantum computing requires traditional semiconductors as an input into the system and an output to the system. So we're going to be around for a long time, and our technology is highly strategic and relevant. And because the United States invented the industry and today still leads the industry in most regards, this is a tremendous advantage for U.S. economic leadership, national security, and long-term sustainable growth, and is exactly the kind of industry that the U.S. needs to lead in, particularly as it faces new great power competition from countries like China. However, the U.S. is not scot-free in terms of supply chain vulnerabilities. And we learned last year during the pandemic what that means in a pinch when you require access immediately to essential goods and services, particularly like personal protective equipment that was so necessary for our first responders last year. Clearly, we don't want that to happen in another instance, whether it would be a natural disaster or geopolitical tension that would exacerbate supply issues in the semiconductor industry. We got a taste of what could happen due to the ongoing shortage in semiconductors that happened during the pandemic. It started with the auto industry. However, it's not just autos, it's almost every end segment that is a customer of semiconductors due to a kind of historical supply-demand imbalance thanks to due to the pandemic, has meant that there just isn't enough currently supply to meet the demand, whether it's for cars, gaming devices, personal computers, even toasters. And for example, a good college friend of mine was renovating his kitchen. His dishwasher is on a 3-month back order because it's missing the microcontroller that's needed. And he was complaining that I'm at the SI, I need to solve this for him. So it's really hitting, a lot of aspects of our daily life. But I would say that this is just a taste of what could happen if we don't resolve some of our critical supply chain shortages. The good news is that the shortage we're facing now over time will correct itself as economies come out of lockdown, as demand balances go into a more normal range, demand supply balance. But overall, we project there's going to be a 5% growth for semiconductor technology on a compound annual basis through 2030. As a result, there needs to be a 50% increase in semiconductor manufacturing based on 2020 levels to meet that demand. And right now, the U.S. is faced with an overall environment where we lead in semiconductor design and research, IP-intensive activities like the manufacturing equipment. We have around half of that market. However, when it comes to the more capital-intensive areas of the semiconductor industry, like manufacturing, around 80% of that now happens in East Asia. And that's primarily because other governments have understood the strategic importance of semiconductor technology and have gone out of their way to prioritize semiconductors and manufacturing as an industry that they want to support. And in fact, as a result of this, semiconductor manufacturing in the US is now anywhere between 30 and 40% more expensive than it is in East Asia. And the biggest contributor to that cost difference are government incentives. So for example, Singapore or Taiwan or Japan, South Korea, they have very sophisticated industrial policies that promote manufacturing in their country. And as a result of that, again, 80% of that semiconductor manufacturing happens in Asia. At the leading edge, while of course, from a volume perspective, as Susie pointed out, it's only about less than a quarter of semiconductor volume. It's still strategically important. And 100% of those leading edge semiconductors are now produced in 2 locations, Taiwan and South Korea. And I think due to the developing geopolitical tensions, it's certainly not tenable from a long-term U.S. economic and national security perspective to have that type of dependency. So what needs to be done? Fortunately, lawmakers on both sides of the aisle, starting from last year, have begun to recognize this issue and develop the Chips for America Act, which are a slew of helpful incentives from grants to research investments that will help turn around the tide and initiate a revitalization of a renaissance in semiconductor manufacturing, design, and research here in the United States. Specifically now, President Biden has proposed $50 billion for the Chips for America Act in his infrastructure package. This was also included in the Endless Frontiers legislation that Senator Schumer and Young also introduced on a bipartisan basis. And we think this will go a long way in helping the United States regain its leadership position in semiconductor manufacturing technology. It would help us to rebalance supply chains, not completely, but rebalance them. Here, we have a little bit more of the necessary manufacturing here on U.S. soil. And it would also, because there's very significant investments in research and development through things like a National Semiconductor Technology Center or research programs at DARPA, help the United States in the design and the research phase of semiconductors maintain its leadership position. So we think it's a very holistic portfolio of investments that the U.S. should be looking at to help sustain our semiconductor leadership, because our goal at the end of the day should be able to be way ahead of the pack in terms of semiconductor leadership, particularly as it relates to China. And again, I wholeheartedly agree with Susie's comment that ultimately it's how fast can we run in the race to maintain our leadership position in semiconductors. So happy to go into the Q&A, Dan, but wanted to provide some opening thoughts about where we are and where we could go in terms of semiconductors, and just sort of end with one final point is that, this has been a long-term trend. In 1990, the U.S. was manufacturing 37% of semiconductors on U.S. soil. Today, that's down to 12%. So, what could we do collectively with industry, with government, also with our allies? For example, there's opportunities to partner with Europe and other friendly nations like Singapore, allies, to help us solve some of these problems together. I think that's another topic that we could include in the discussion. So anyways, back to you, Dan, and happy to take questions and engage in the discussion.
Thanks, Jimmy. And I have some questions, as Jimmy mentioned, we'll get into here, but I invite those of you tuning in, please do submit them in the Q&A function. We can curate your written questions there and bring them to our panelists. First and foremost, I'll kind of toss it right back to you, Jimmy. In breaking down the semiconductor shortage, is it a business planning problem with just-in-time supply chains? Is it geopolitics, the where the supply chains are and the policies? How would you provide a taxonomy or an autopsy of this shortage?
Yeah, it's really a perfect storm. First, you had the pandemic, a once-in-a-century pandemic. Second, we have geopolitical tensions. Third, geographic concentration and supply chain issues. And all of this really concocted together to create what we're facing right now, this unprecedented supply-demand imbalance for the semiconductor industry. As COVID-19 hit in early 2020, countries across the world started going down into lockdown mode. In particular, China in January and February of 2020, the home of 36% of the world's electronics manufacturing, did shut down a lot of their manufacturing plants for a brief moment, comparatively, sometimes weeks, some up to a month. So that certainly knocked off a significant amount of supply for the semiconductor industry and introduced difficulties into the supply chain. Then as the lockdowns around the world grew, other parts of the world like Southeast Asia, Mexico, also going into lockdown, sent a number of semiconductor plants and downstream customers' facilities into temporary shutdown or a pause in operations. At any time that kind of big supply shock happens in the industry, you're going to create downstream problems later on. However, the unique thing about COVID-19 is that while everyone went into work from home, study from home, play from home, I don't know about you, but my kids bought a new iPad, new displays, computers. People are buying microphones, cameras, everything. That meant demand for semiconductors throughout the pandemic didn't dissipate; it actually increased. And so semiconductor companies were working very hard in a challenging environment due to supply chain constraints to try and meet that demand. The auto industry, however, they forecasted that no one would be driving around during a lockdown, let alone purchasing a new car. And so in order to preserve their operations, they canceled all their orders from their suppliers. And that basically means they went to the back of the line if they wanted to get new chip orders, because semiconductor companies don't just put a pause on their factories and say, we're just going to leave this here for you. Rather, they had this burgeoning demand from all these other important segments like medical devices for the pandemic ventilators, and they met that with that chip supply. Now, in the fall of last year, the auto industry then saw a surprising rebound in auto growth for sales. People started buying cars. And because of that, the supply was already fully constrained, meaning that factories are running at full output. And auto companies had an issue if they're not able to buy the semiconductors they need immediately because they were now in the back of the line. The good news is that semiconductor companies are working really hard over time to try and meet that new level of demand that's out there. However, there's no silver bullet. semiconductors take about 26 weeks to be produced, while cars take about 3 days. They run a just-in-time inventory, meaning zero inventory. So they have no chips in their stockpile to sit on to try and ride through this. So I think there's a lot of lessons learned here. Maybe just-in-time works in a perfect environment, but you need some sort of inventory to help you get through rough waters like a pandemic. And not all auto companies had the same issue. But now that this demand is just booming, with the US economy coming back online, it's clear that this shortage is going to last maybe through the end of this year. However, it's going to improve. So overall, I think, again, a number of different factors, and then adding on top of all of that were the geopolitical tensions between the US and China. And it's the reality that Huawei or SMIC, when they were placed on the entity list, for some reason, the US government chose to message for like 9 months they were going to do that, but didn't do it. So naturally, the Chinese companies stockpiled massive amounts of components. In addition to that, other companies in China are worried that they too could be next. Are they going to be on the entity list? And so they're also starting to stockpile a huge amount of components. So from an inventory perspective, meaning extra components sitting somewhere in a warehouse, a lot of those were dried up because of the trade tensions in 2020. So again, perfect storm. Will this happen again? Hopefully not, but we certainly should be prepared if it does. And I think, again, it's a combination of better supply chain management, more smooth geopolitical tensions, and ultimately, longer term, how can we enable more production to happen here in the United States? Because new fabs will be built, facilities to make chips, but we should make sure they can be built here.
If I could just add, Dan and Jimmy, on that point, that's an impressive analysis of the whole COVID. I think that's like COVID for techies in 4 minutes, Jimmy. We believe that COVID is in some ways, and the pandemic is in some ways, for all the reasons that Jimmy described, is a spike, and that's why it's particularly bad right now. However, we don't believe. We believe that it's not going to go back to whatever rate of growth that we had before the pandemic, because if you look at things like 5G and you look at the digital transformation, if you will, and the promise of the digital transformation, the usage of semiconductors in every aspect of public and private life is only going to increase for all the right reasons, to take advantage of those kinds of technologies. So it's I haven't seen a model of it, but I would think that the graph is going to look like a bit of a spike for the pandemic and things ease up a little bit. But I think these conversations about what we do in the 5-year time frame and what we do for manufacturing are really, really critical. You have some pundits saying, well, this is just a spike, and fabs have to run at 97% capacity to be productive. So companies are going to be hesitant. But I think that's also where the government steps in, and maybe we don't want to get into a conversation on industrial policy here, but there were comments earlier there. When you're looking out 5 years and you're looking at a whole digital transformation, you really need to look hard at some of these issues and what the 5 to 10 year future is going to bring. And we believe this problem is not going to go away as we come out of this pandemic.
And if you look at for example, the chips that the auto industry needs, it's generally not the most advanced chips. About 60% of semiconductor consumption for autos are analog chips, which are much older. About 35% are logic. However, those are on older manufacturing technologies. And China and Taiwan are really the only two countries in the world that are adding massive amounts of that trailing edge mature technology. And in the future, that could have strategic implications where our auto or industrial sector, aerospace, could become more dependent on those type of manufacturing facilities, because from an investment perspective, putting in new old technology doesn't make a lot of sense. It's very hard to make a return on investment. However, in China, it's called the China CapEx discount, meaning it's free. You don't have to pay for it. The Chinese state subsidizes it. So it's very difficult then for anyone in Singapore, Europe, the United States to compete against that model. However, so if we think this is a strategically important technology, our view is that we need to compete, make the US a competitive environment for semiconductor investment. We don't need to look like China. We don't want to emulate their model. We don't want national state-owned enterprises and government funds, but we can go a long way to try and make the US a better place to invest.
Thanks, Jimmy, and yeah, thanks for breaking it down and how we look at it. Truly helpful, I think, for the policymaker, business folks to understand this. But looking at the various sectors, and not all are the same. Susie, you all at Qualcomm, handset providers, telecoms. You also have a chip in the new helicopter on Mars, I understand as well. So obviously, major clients, very bespoke purposes. But what are some of the demands of these key sectors as we think of investments in manufacturing? What are we going to need to focus on for important sectors, perhaps even including, as you mentioned, AI, machine learning, 5G, quantum, et cetera?
So, it's all of the above. And that's too broad of an answer. But I'm going to bring it back to again the legacy node chips, the mature node chips. There will always be, even if you redesign your PMICs in smaller process technologies and such, and it's unclear. You've got to do the economic balance there. You're not going to design those in 7 nanometer process technology. You're always going to have a need for these accessory chips and chips that are done in they don't demand the leading edge technology. So from my point of view, that's a really important piece of the conversation is how do you reduce, how do you we are in kind of a global pickle with such a concentration, a geographic concentration of both leading edge and legacy node chips. But how do you? But it's an incredibly complex supply chain, and how do you don't just say, okay, I'm going to put in a set of policies. We're going to move all of this supply chain. I don't even know if we can find all of the supply chain, out of certain areas and into U.S. allies or into certain areas. So I think there's got to be a holistic look at. I think Jimmy said it right, at the balance. How do you strike the right balance so you're not so exposed to Taiwan, versus saying, okay, we're going to move the entire supply chain to the U.S. or to U.S. and allies. So we've got to figure out what that balance is, and it's got to include not only the leading edge chipsets, but all these ICs that go into these devices. And I think in the automotive industry, somebody said there's like in a regular old car, there's like 3,500. A 2020 car, there's 3,500 plus semiconductors. I wish I had a really good answer for you, but I don't.
Jimmy, anything to add?
No, I think Susie covered it well.
So some of these proposals we're seeing in Congress now. You talked about endless frontiers, the CHIPS Act. How does that stack up, with the immediate challenge resolving itself versus, do we need to think of that more as preventing the next challenge than an immediate solution to what we face?
Yeah, I'm happy to take that one. I think overall, while there's been some pretty extreme calls for supply chain interventions by different parts of the economy, things like mandating some factories increase output for one sector over the other. That's just a dead end. We'll just create one crisis by trying to solve the current one. And if we say that, one factory has to produce all of the orders for the auto industry, then what happens to the medical device the devices that rely on semiconductors too, or the tablets that are going to first responders and hospitals because everything is now digitalized. So again, we really need to let the market correct itself in the short term. In the long term, it's about how do we ensure that a future crisis is not worse and repeats itself. And that comes to the CHIPS Act. In fact, one concept that we've been talking about that was introduced by the Cybersecurity Solarium Commission is minimum viable capacity. What's the minimum viable amount of manufacturing capacity the US needs for strategic goods so that we have just enough onshore supply at resilient levels of technological capability to meet our needs for national defense, aerospace, critical infrastructure, and first responders. So it's saying in the next crisis, say it was a geopolitical conflict or another pandemic, and we wanted to ensure our essential services could stay running, what kind of semiconductor production would we need? We've actually done some analysis, for example, at the leading edge. We think an additional 3 new foundries would be able to sustain that level of minimum viable capacity for the leading edge. On a lagging edge, we probably need about 5 or 6 other factories. And overall, our analysis shows that $50 billion in incentives could actually help us achieve that viable capacity number for a wide range of technologies, both leading and lagging edge. And so, that's, I think, a helpful framework for us to consider this because, again, there's no one company or country that can have everything on their own shore in the semiconductor industry. It's too complex, too disaggregated. Materials are coming in from Japan, lenses from Germany, and substrates from Malaysia. To try and put all of that in on our shore, actually we calculated would be around $280 billion of government investment, plus another $900 billion of private sector investment to try and achieve that. And it's not necessary because we have friends around the world that are part of this sort of safer supply chain. So again, I think it's thinking about what's that minimum viable number we should try and achieve. And the good news is the CHIPS Act is well-rounded and I think would help us address that.
And just to add to that, we are thrilled to see these conversations and these policies, things like the CHIPS Act and Endless Frontiers Act coming out. If you think back, maybe a year ago, this wasn't even in the national conversation. So I think it's phenomenal. And to Jimmy's point, the short term is challenging. And by the short term, I mean between now and 5 years, because it is so complex to not only build capacity and build manufacturing capacity, but build it so that companies actually get reasonable yield and reasonable quality out of what they put there. It's not simply a matter of money. It's a matter of talent. It's a matter of commitment by the manufacturer, the fab, the customer, if you will, with all of their engineering knowledge and sort of secret sauce, and the tools companies. And so all of those pieces, fortunately in the US, we have a major portion of those, the design companies and the tools companies, and we have the will to look at fabs on US soil. So but it's far from a given. So it's not a matter of this much money and 5 years and we're home free. I think we need to have policies that support the companies that not only build the fabs, but participate with them from an R&D point of view. The tools companies are a really, really critical part of this equation. And my boss actually has, I will steal a term from my boss, a quote from my boss. He says, the best time to plant, if you want shade, the best time to plant a tree was 10 years ago. The second best time to plant it is today. And so these conversations and the movement of the CHIPS Act, I think, are really important so that we, in 5 years, we're not in as bad or likely worse situation than we are now.
Yeah, I mean, building a new CHIPS Act, just to build on Susie's point, can take up to 2 to 3 years, particularly for the leading edge technology. These are $20 billion facilities that are 3-4 times the size of football fields, up to 1 million square feet, for a massive memory fab, for example. These are huge. They have over 1,000 manufacturing process steps, and everything needs to be calibrated perfectly to run your recipe for how to make those chips. And also, if you think about it, these are huge commitments. It's kind of rolling the dice, because you're going to be building a fab now that will be operational probably in 2 years, high yielding in volume maybe in 3 and 4. You're just hoping that the demand is going to be there for this big facility you're putting down. So it's a tremendous amount of risk that companies undertake in semiconductor manufacturing, and that's why sometimes they're hesitant to overcommit, to race and build all sorts of new capacity, even in an environment like right now, because yes, it's going to be booming for the next 4 or 5 years, but you just want to make sure that you're going to still be profitable when that window closes.
But even with some of those pressures, what is the industry doing right now, absent government, to adjust?
Yeah, so we're doing a couple of things. So one, as Susie mentioned, our factories are running at very high utilization ratios, meaning how many of the tools and the output of your factory are you actually converting into chips? And on an average day, we say about 80% for a foundry is fully utilized, because you're always taking some equipment offline to repair, you're servicing, you're doing upgrades. Now our industry is about 95 to 98% utilization, and they've done that by delaying those equipment repairs, delaying upgrades, eking out whatever more they can gain out of the equipment that they have in their factories. They're also doing tests in the supply chain to make sure that companies aren't double ordering, triple ordering. So they are asking for guaranteed purchase orders and other things from customers. And they're also having those hard conversations with customers around the world, saying, where are your products used? How can we make sure that, we're making the right decisions? Because right now everyone is in allocation mode. Companies have set up war rooms to try and manage all these different customers. So we're doing a lot. And it actually makes the industry a little bit more brittle. For example, if you're running a factory at such high utilization, delaying repairs, you can have flare-ups happen. Like, for example, there was a fire at a factory at a Japanese supplier of semiconductors, and that could have been due to some of these delays in repairs and other things. So we're basically pushing everything to the limit in terms of supply.
And I think there's a question here. It's interesting that looking at how in the longer run they mention accounting rules as one way to look at inventories. And usually you call the audience for a doctor, not an accountant. I don't know anything on that topic. I don't know how companies might be looking at that. Is there anything in your all's experience on that?
I'm uniquely unqualified to venture. Yeah. I'm sorry.
Yeah, well,
I'm not an accountant. I do know that overall, we could make particularly our tax structure more optimized for manufacturing. For example, there are other countries like South Korea, Japan, Singapore, Germany have what are called as manufacturing investment tax credits. Right. You invest $1 in capital expenditure, you might get 20 cents back from the treasury. All sorts of different things. You could allow, for example, changes in the tax code for companies that are creating inventory. As they've mentioned, that's one of the issues, is we have this very lean, just-in-time inventory that is really, really great, except for when you're in a crisis. And so I think, again, one of the learning moments from this whole shortage is that companies are going to have to start building some sort of inventory. In fact, some of the automakers, particularly from East Asia, in Japan, in South Korea, they've had issues of major earthquakes and tsunamis, and they've learned to build an inventory. And they were actually faring much better throughout the auto shortage than some of their competitors because of that.
And I will just add one perhaps controversial comment, that companies and governments should continue to look at, that in the short term, some of the geopolitical concerns with doing, manufacturing in places like China, if it's old enough manufacturing, that it typically doesn't represent much of from my point of view, much of a security risk, and that's something that is in the conversations about decoupling from China and cutting off both supply and markets. That's something that tends to be top of mind for us, because I think if you do that kind of thing without really understanding the unintended consequences, you can really add gasoline to this fire that we're in.
Right now, I think the complexity of this, where you want to protect the technology at the high level, which is a different conversation from your supply chain reliability and resilience at the lower level, but they're all lumped in as a semiconductor conversation. So we have to be clear on that, and we think through it too, Jimmy, in your report, and looking at those, the truly advanced node, where we saw so much of our reliance is on Taiwan and South Korea. Many of the questions, we see this as bad now. And you mentioned it, it's not just war, although that's what you see on the cover of The Economist, and, North Korea always there, but seismic threats and challenges there. How worse could this be if there were a truly, disastrous situation in one of those key countries?
Well, what's interesting is in semiconductor manufacturing technology, there's a really key aspect called your process technology. The process is, what's your recipe you use to integrate all the tooling, the type of chemicals and materials needed to make the chip and the transistors smaller. That's essentially Moore's law. The US historically has led in the advancement of Moore's law. That was primarily Intel, to a lesser extent, IBM, AMD, Micron to a lesser extent. And however, over the last 5 years, the US has fallen behind in process technology. Now, Taiwan, TSMC, South Korea are ahead of Intel. But more importantly, business models have also changed, where Intel is vertically integrated. They're captive, meaning they only produce for themselves. While TSMC and Samsung produce on a foundry basis, meaning they produce for fabless companies like Qualcomm and take their chip designs and manufacture them. So even though Intel was at the leading edge 5 years ago, they weren't a foundry. So we still had a strategic dependency issue. The interesting thing is that if Intel were at the leading edge, 36% of leading edge capacity would be in the United States. They have a huge manufacturing presence here. They also have said they're getting into the foundry business. They've announced a new foundry business, but that's going to take, I think, a couple of years to mature and grow, and there's a lot of challenges. Basically, what that means is, for the short term, we're stuck with Taiwan and South Korea. They're very good business partners, very good technology. They're important contributors to the ecosystem, and they power a lot of innovation in our industry. The good news is that TSMC has announced that they're looking to build a factory in Arizona, which is, I think, a very good first move. There's been reports that Samsung as well is considering a new factory in the United States. Intel has announced 2 new fabs. But those are going to be steps in the right direction, and that's going to help us rebalance some of that dependency. But in the event, for example, we modeled in a recent study with the Boston Consulting Group that today the world was without access to semiconductors from Taiwan writ large, that would lead to a $500 billion loss for the electronics industry. And even further from that, if it was extended by 2 years, it would be compounded. And basically, it'd be the auto shortage, but 100 times worse for every segment in the economy. Virtually everything electronics would not be shipping. And that's obviously to benefit of no one. It's not to the benefit of the United States. It's not to the benefit of China. In particular, China consumes more of those devices than we do. And because of Taiwan's relationship in the semiconductor supply chain, it's not a one-way dependency. It's a codependency, where Taiwan's factories and supply chains rely on all sorts of inputs from the US, from Japan, Germany, South Korea. And so in some sort of event where Taiwan were cut off, they would be cut off for everyone. including China, most likely. So again, it's a lose-lose situation for everyone involved, and it would be, a terrible outcome. And that's why I think we need to work with our allies and partners, the government of Taiwan, to improve their resiliency and supply chains to prevent something like that from happening.
What too can we do? Taiwan is one. Our partners in Japan, Europe. How can we further cooperate with them on resilience and R&D, other areas of coordination?
You want to take that one, Susie?
Yeah, I can start. The multilateral aspect is really critical, and especially I think you have to play to every region's strength. And as I look at Japan's generally very proficient, Japan, Germany, and the U.S. very proficient in the R&D space, and being able to enhance that and support that, I think makes maybe more sense than saying, okay, we're going to put the equivalent broad swath of manufacturing plants, in Japan, the U.S., and Germany. So I think taking a look at where each region has expertise and has incentive to put that, you come up with this a more holistic picture. But I think the U.S., I guess the bottom line for me is the U.S. can't do it alone. It's just perhaps nonsensical to think that we can, even for critical technologies, that we could do the whole supply chain in the U.S. I don't think that's feasible, even if you could figure out what that supply chain actually was. So I think again, maybe you do manufacturing in South and Central America, and some of our allies there as well. Maybe you play to Japan's strength, and maybe you play to Japan's location in Asia. I don't know if you have anything to add to that, Jimmy, but.
Doing what we can to encourage Taiwanese investment here in the United States certainly can be helpful. Also, getting our own house in gear. If we have competitive companies, if we had alternatives to some of the Taiwanese or Korean companies, that would be a huge improvement for the United States. But again, it's a long-term issue. It's not going to be a short-term one. Europe is talking about making significant investments in semiconductor manufacturing. So is, as Susie mentioned, Japan, Singapore. What can we do with our allies together? If some manufacturing just may never be cost competitive in the U.S., particularly at the lower end of the technology. So maybe it's not a onshoring, but a nearshoring conversation of areas that are also interested, like the government of India really wants to get into semiconductor manufacturing. They have some huge challenges they have to overcome before they get there. But if they could, that would also be another strategic alternative.
Thinking longer term, and Susie, the quote you borrowed from your boss is perfect for this too. Education, immigration, the workforce for semiconductor competitiveness. How important is that when we're looking at the what we'll need the folks designing chips, running manufacturing in the future? What are those skills that we need to develop and bring from overseas as well?
I think that's a really important piece of the conversation. And there was an article with a quote from Morris Chang, who is the founder of TSMC, whose view I actually agree with is, one thing the U.S. lacks at this point is the kind of expertise to do this high-end manufacturing, and so it's and I've been involved in a lot of sort of workforce and STEM initiatives at Qualcomm, and as I see it, it's a little bit of a chicken and egg problem, because if you don't have, say, fabrication plants in the U.S., your universities and your technical colleges are not going to turn out people. Kids go to university, and universities turn out people that they think they can get in areas they think they can get a job. So you have a little bit of a chicken and egg thing going here. But we have one of the best upper education system in the world, in the U.S. And so I've got to believe that that's pretty easily surmountable. And we need to plant that tree now too, because these kids are all hopefully in high school, and most of these are probably 4-year plus degrees. And the other point I'd make on that is there's been a lot of discussion. Well, how many jobs will these kinds of advanced manufacturing, how many jobs will they generate? Well, it's a lot. It's like 1,000 people to run a fab like TSMC is putting into Chandler, Arizona, because you've been when you tour a fab, it's all a clean room and it's all robots, and you think, well, okay, so there's 2 guys running the actual machines. But another analogy that one of my colleagues talks about is it's like your car. The car in your garage has to be taken in periodically to be calibrated and to have the oil changed and reset. And if you had an old Volkswagen Bug, you had to reset the points years ago. And think of a fab as being the entirety of San Diego's cars. So all those machines have to be constantly recalibrated, measured, tuned, and those are all high-skilled jobs that are good jobs, high-paying jobs, and that we can build the expertise in. But again, it needs to be a part of this holistic approach to actually, bringing the manufacturing onshore. So it's not impossible, but it has to be a piece of that system, or nobody's there to actually be able to run these machines.
Yeah, there's really, from a jobs and a workforce perspective, the interesting thing about the semiconductor industry is you have demand for highly skilled, highly educated jobs. At the same time, for a lot of the fab and factory technicians, which account for about 40,000 of the 180,000 person workforce in semiconductor manufacturing, there's another 70,000 fabless chip designers in the United States. About total, we're out 230,000 jobs here in the U.S. for the semiconductor industry directly. But the technician who maintains the equipment and manages the operations, the facilities, a lot of those only require an associate's or a technical degree, and so there's opportunities for a lot of good blue-collar jobs. However, at the very high end, to develop that semiconductor manufacturing process technology, you're really requiring PhDs in bleeding edge basic science and material areas like physics, optics, metrology, chemical engineering, electrical engineering, artificial intelligence, increasingly applied in the fab to predictively predict yield and manufacturing defects. Some of the manufacturing equipment literally comes with a team of 20 PhDs just to operate them. That's the high-end extreme ultraviolet lithography. It's not that we don't necessarily lack people that are trained in those areas, but the challenge is that more than half of them are foreign-born, and we don't do enough here in terms of our immigration system to encourage those that we train in our schools to stay here. If you look actually at the executive management team of Samsung and TSMC, they're almost entirely trained in U.S. schools. Berkeley, Caltech, Stanford, MIT. Basically, those are the 5, maybe University of Illinois, Urbana-Champaign, great school for engineering. Rochester, maybe for optics. So how can we get more of those engineers to stay here? Things like stapling a green card to a graduate degree in those areas, because ultimately, if we don't keep them here, they're going to go overseas and create competition for U.S. companies. And then ultimately, what can we do to get U.S. students more interested in science, chemistry, engineering? People who are studying in graduate school or undergrad, they want to be a product manager for the search widget on Gmail, or help Uber sell more services, etc. Semiconductor engineering is just seen as kind of boring. So we, as an industry, need to do more to help invigorate student interest. And there's some helpful foundations and programs that are trying to get K through 12 students to go see a fab. It's pretty dang cool if you've been in one, and it can be kind of life-changing once you see one. And I think things like that we can do in partnership with public schools and otherwise can really help us turn things around.
Yeah, I think those kinds of programs to take kids to see these kinds of things. It's like, I know so many kids who want to, they toured NASA, so they want to be an astronaut. But I think we can do that with fabs as well, because it is very cool, and it's not impossible, but it's a bit of a cultural switch as well. And once your points on immigration are very apropos as well. Once you get critical mass of perhaps those immigrants here, then that helps bootstrap the rest of the industry, and you don't have that chicken and egg problem.
Well, I see, this conversation could keep going on, I think, for hours to go into this and the challenge we face. But I want to thank you both for joining us. And Glenn, before we part, do you have anything to say? Glenn,
I
thank
just
you.
want to say it was a really helpful, informative discussion. Thank you for our panelists. Thanks, Dan, for managing it. I'm sure this will be a continuing part of a series because this is an ongoing question. But Jimmy talked about some legislation on the Hill. We're tracking that. The issue of working better with allies was raised. We're working on that as well. So we hope to be able to continue to contribute to this discussion going forward, and looking forward to seeing our participants who are with us today back again for another session soon. Thank you. Be well.
Great. Thank you.